Good day everyone. Welcome to another video lesson for General Chemistry 1, Quarter 4, MELC 2, Week 1, Part 2 of Quantum Mechanical Description of Electrons. This learning activity sheet was developed by the PED Region 6, Western Visayas. Okay. Electron configuration is the description of how the electrons of an atom fill up the orbitals. The valence electrons are electrons found at the outermost shell of an atom, and the ones which are directly involved in chemical reaction. Aufbau principle. According to this principle, the electron of ground state atoms tend to fill first the shell, subshell, and orbitals that produce the lowest energy for the atoms. In other words, electrons fill up from lower energy to higher energy. We have here a mnemonic, which is used to remember the order of filling of atomic orbitals during the construction of the ground state electron configuration of elements. So here, this is the mnemonic. How do we write the mnemonic? So first, write number 1 to 7. This will represent the energy levels. Then write S. On the second column, at the level of number 2, write 2 up to 7. Then write P. On the third column, on the level of the third energy level, write 3, 4, 5, 6. You can write 7, but it will not be used anymore, so 6 would be okay. Column number 4, you write 4 on the level here of the fourth energy level, then 5, then write F. So that is the mnemonics. We can write the mnemonics in a straight line. So, just like this. This is based on this one. So, we write it according to the tail head here. We follow the tail to the head and then tail to the head, tail to the head, tail to the head until we finish. So that means it is S, S, P, S, P, S, D, P, S, D, P, S, F, D, P, S, F, D, P. So it's the same here. And if you notice, there is an underline, or they are underlined. It shows the repeating sequence. Let me show you. This is S. Aside from S, of course, there is the repeating of S here. So it starts with SP, SP, SDP, SDP, SFDP, SFDP. So it is easy to memorize. You start writing S and then SP, double it, SP, and then SDP, double it, SDP, then SFDP, then double it, SFDP. Then, the same with what we did here, we will start numbering S. 1. Okay, we start with 1. So 1, 2, 3, 4, 5, 6, 7. And P, we start with number 2. 2, 3, 4, 5, 6, 7. D, we start with 3, 4, 5, 6. And F, we start with 4, 5. And then we know, class, that the subshells, which are S, P, D, and F, have number of orbitals 1, 3, 5, 7 correspond to the subshell. And remember that the maximum number of electrons that one orbital can hold is 2. So we will just multiply each of these orbitals by 2. That is the number or the maximum number of electrons these subshells can hold. So for S, 1 times 2 is 2 electrons, the maximum number of electrons. For P, 3 times 2, 6. For D, 5 times 2, 10. And F, 7 times 2, 14. Maximum number of electrons. So we will write it here. S2, so all the S, you write maximum number of S would be 2. Okay? And okay, all S, you write maximum number of 2 for electrons. Class, remember that this one here, the number, the coefficient, represents the energy level, and the letter here represents the subshell, and the power here, the exponent, represent the number of electrons, the maximum number of electrons here that the subshell can hold. Then all the P, write 6. All the P, write 6. All the D, 10. Okay? All the F, 14. All the F, 14. Okay. Now, using the mnemonics above, we will write the electron configuration of carbon. Okay. We will write the electron configuration of carbon. So what we will do, so carbon has an atomic number of 6, and that means also that the number of electrons is 6. So here, this, remember the number of electrons. We just copy here. 1s2, 2s2, but 2p6, if we write 2p6 here, that will become what? 10. If we just copy this, 1s2, 2s2, 2p6. So, to make it 6, remember the maximum is number of electrons that P can hold is 6, but it can hold also less than 6, but not more than 6. We cannot have P7 or P8, but we can have P1, P2, P3, P4, P5, and P6. So we will adjust this number to have a total of 6 to equal the number of electrons of carbon. So that would become 2. So this is now the electron configuration of carbon. If we will do this in showing or in making the Bohr's model of the atom, it will look like this. So carbon, this is the nucleus, and this one here, the coefficient, is equal to the energy level. So the first energy level has 2 electrons. See, there are 2 electrons. This 2 here, 2s2, 2p2, this 2 here means it is in the second, the electrons are in the second energy level. So we have the 2s and we have the 2p electrons. Okay, so if we add these electrons, it will be equal to 6. And also that the outermost electrons here will become your valence electrons. So 1, 2, 3, 4, the outermost energy level. The outermost energy level will be also the highest energy level in your electron configuration. So without this Bohr's model of the atom, you can identify the valence electron by just looking at the electron configuration. So we have the highest coefficient here is 2, and then you have two coefficients, so you need to add this to 2 plus 2 valence electron is 4, which is equal to this 1, 2, 3, 4. For example, there is only one, uh, for example, this is the electron configuration. So there is only one coefficient here that is highest. So what you have to write as the valence is also 2. There is no need to add this because there is only one coefficient here which is the highest. Okay, then let's go to the Hund's rule. It states that electrons pair only after the orbitals in the same subshell are filled with single electrons. So going back to the electron configuration of carbon, here the subshells or the orbitals are represented by the boxes. So this would be 1s2. There are 2 electrons here inside. 2s, 2, 2 electrons. And then the 2p, there are 2 electrons. But remember that the p has 3 orbitals. So this is 1 orbital for s, 1 orbital for s. But p, there would be 3 orbitals. So uh, based on Hund's rule, that when an electron will enter a subshell with more than one orbital, it should enter in the same direction before pairing up. Okay, so they have to fill this up in the same direction first, and then if there are extra electrons, then that is the time they pair up. So this one here do not have an extra electron. So they haven't even filled up the whole 3 orbitals. So this would be the arrangement for carbon. So there are 2 here which are unpaired. This is the wrong or incorrect way of writing it. Okay, this is the right way of writing it. Then let's go to the magnetic property of an atom, diamagnetism and paramagnetism. So, atoms with all its orbitals filled with paired electrons are diamagnetic. Example, beryllium. And atoms with unpaired electrons in its orbital are called paramagnetic. Example, carbon. Okay, let's see. So, beryllium is diamagnetic. Why it is diamagnetic? This is the electron configuration of beryllium. 1s2, 2s2 because the atomic number is 4, so the number of electrons is also 4. So 4, 1s2, 2s2, 1s2, 2s2. That means there are only 2s. Okay, so 1s here is paired, 2s is paired. For carbon, it has an electron configuration of 1s2, 2s2, 2p2. So this is for 1s2, this is 2s2, and this is for 2p. So these are unpaired. So carbon is paramagnetic. Okay? Because atoms with unpaired electrons in its orbital are called paramagnetic, while atoms with all its orbitals filled with paired electrons are diamagnetic. Okay, let's have now your activity proper. Activity 1, the boarding house analogy. You only have to write or identify whether it follows the Aufbau principle or the Hund's rule. Okay, you read the situation and identify. It's easy. Then let's go to activity number 2. Complete the table below. Okay, so now neon atomic number is 10. Electron configuration. So here again, we will have to count. So this is 2, 4, 6. So it's equal to 10. All we have to do here is to copy this. Okay, copy. So 10. How about oxygen, which has an atomic number of 8? So we copy also here. It's here now. But remember, if we copy, it is 10. So we need to uh, change this 6 to a number which the total will become 10. Okay, remember that a P could be P1, P2, P3, P4, or P5 and P6, but never P7 or 8. So now to make it 8, this 6, we need to change it to 4. 2, 1s2, 2s2, 2p4. So the total is 8. Now, how about the valence electron? So remember that the higher or the highest coefficient here would be the outermost energy level, and you just need to copy this electrons add here 2 plus 6. So the number of electrons here would be, or the number of valence electrons would be 8. How about for oxygen? Same. That would be 2 plus 4 is equal to 6. Now, if there is only one number here, okay, remember that if there's only one here, your valence would be only 2. Okay? Now, is this, what is the magnetic property of neon? Remember neon? Okay? Here, neon. This would be 1s2, 2s2, and this would be 2p6. There are only 3 orbitals for p, so there are 6 electrons, so that means they are all paired. If it is paired, it is what? Diamagnetic. Okay. Then how about oxygen? Oxygen is this one here. 1s2, 2s2, and 2p4. So it will fill this up first in one direction. Okay, 1, 2, 3. And then because there are 4 electrons, there is an extra 1 electron, so it will come back here and pair it. That means this one here is the last electron uh, to get inside the orbital. Okay, so there are unpaired electrons. So if there are unpaired electrons, it would be what? Paramagnetic. Magnetic. Okay, now, do you need to write this so that you can answer this one? There is no need. Okay, just remember that P has 3 orbitals, and the 3 orbitals could have a maximum of 6. There are only 4 here. That means not all of the electrons inside the orbitals are paired. Understand? Okay, so you do sodium, calcium, aluminum, chlorine, bromine, iodine, and strontium. Okay, and then after that, you can answer the reflection, compare the statement, complete the statements below. I understand, I don't understand, I need more information about. So, if you learned something new from this lesson, please like and subscribe. If you already subscribe, I greatly appreciate it. Thank you so much. God bless and stay safe.